In this episode, we will look at the solution file, which provides the information about how GWM is to solve the optimization problem, and we'll do a little demonstration of running the code. Here we are back in the distribution directory for GWM 2005 version 1-5-2, and moving to the data directory, we see the dewater problem, and there we find the solution file. Opening that file, we find quite a bit of information required. We'll be discussing this in a future series of episodes because there's a lot of details involved in setting up the solution algorithm for the optimization problem. In this simple case, the dewater case, we use a linear program to solve the problem. That is indicated in this file by the use of the LP character in the solution type, and we supply other parameters as well, which will be discussed at a later time. One parameter, or a couple of parameters to point out at this juncture, are the number of iterations, LP it max, which we've set to a large value of 1,000, recalling that the number of iterations expected of the linear program is roughly 1.5 times the number of constraints. For the dewater problem, there are 10 constraints, so we would expect something like 15 iterations required. So this is a very large cap on that. The other parameter is in the fourth line. This is delta, which is related to the size of the perturbation used to calculate the response coefficients. And again, that'll be described in more detail in a future episode. Finally, I'll just mention the IRM parameter, which indicates to GWM how the user would like the response matrix reported or calculated. And we're going to be writing that to, by this instruction number 3, we'll be writing that to a file, and we'll take a look at that a little in a few minutes. Returning to the GWM file, which is called from the modflow name file, we see that we've got all the files set up, and we've taken a look at all of them. The DECVAR, decision variables, objective functions, variable constraints, head constraints, and now the solution file. And again, the output will be directed, using the keyword out, will be directed to this file. We'll see that in a little bit. So now returning to the distribution directory, I'll point out a few things. If we go to the bin directory, we find the executable for GWM 2005. Once again, the source code used to generate that executable is located in the source directory, primarily Fortran source code. Note that the source code includes both the modflow source code for a particular version of modflow and the GWM source code. And then finally we have the test win directory, which contains executables, or batch files rather, which run modflow. So let's take a look inside this batch file. So this is organized. We're now inside the batch file, and it's organized to move up one level, go into the bin directory, find the executable, run that executable. The executable will be looking for the name file of the modflow problem, and this operates just as modflow does. So that the name file will be located from this directory up one level into the data directory, the dewater directory, and then the dewater.name directory, file rather. And this file, the dewater.name, of course, includes the GWM file. So we'll now go ahead and run this just by clicking on it. And it opened a DOS window here. And we can move through this window. So this is the output from GWM. First, it reports that it is a particular version of GWM distributed on a certain date, September 2015, September 11th, and that it was produced from ModFlow version LGR 2.0. We see output similar to that found in ModFlow. And then we see the actual operation of GWM. We see the beginning of the solution algorithm, running the base flow simulation, and then calculating the response matrix. We perturb each flow variable in turn, and each of these represents a simulation run. We solve the linear program, we find an optimal solution, and then we run a final simulation using that optimal solution. This is the output that's directed to the screen. There is much more detail provided in the GWM out file. We're now back in the test_win directory, and if we sort by modification of files, we see that we've just run the GWM out file that's just been produced. And here it is. This is described in detail in the next episode, but it provides input echo, details of the solution algorithm, and details of the solution. We also see the ModFlow list file. This is the usual ModFlow list file with all the usual information about the ModFlow input and output. This is for the last run conducted, as it says at the top here, the final flow process simulation for GWM, because of course GWM is running ModFlow multiple times. And next we have the RM out file. This is the response matrix, and looking at that file, we see the response matrix for this problem. We have 10 rows, and the rows are the 10 constraints on head, and we have 7 columns, and these are the decision variables, 7 decision variables. So each of these values represents the change in head at a particular location with change in pumping at the particular location. So here we have, for example, 0.797 is the change in head at location 1 with change in pumping at location 3. And this can be very useful to look at this just to understand the characteristics of the problem. So in the next episode, we'll take a close look at the output file the GWM produces, the GWM out file.